a negative a to both sides of the equation. Add my negative a. Now here, both of the a's cancel out to give you 0. You get 0 plus b equals c minus a, or c plus a negative a, which comes out to c minus a, or the difference between c and a. So here, we have b is the difference. B is the difference between C and A. So you write this here. So if we have first a given equation, if this is our given equation, and from that we can deduce that 3 things. The first is what we're given. The second is what we found, and the third is also what we found. How they relate to each other. You see, here on the left side, B is positive. But if we move it to the right side, such as we have A equals C minus B. When we put B on the opposite side of the equation, on the right side, it's negative. And it's likewise for A. Do the same thing with A. Now, let's say if we have, let's say A equals 2, B equals 4. And what does C equal? Here, we say A and B are our known variables, and C is the unknown, which they also use the term X. But for me, when I'm calculating, I usually look at that as a variable. I like to use, specifically when we're talking about something that's unknown, I like to use the symbol of a question mark, which can be used the same way as any other variable instead of X. I like to use a question mark, because I know it's asking the question, meaning I don't know. Now let's say we have, we're going to have 2 plus 4. We'll see. What does C equal? Well, we don't know yet. We have to take a step down and calculate that. 2 plus 4 equals 6. So therefore, C equals 6. Or 6 equals C. Now if we plug this value back in, for 6, we have A, meaning E is 2, B is 4, C is 6. What if you wanted to check this and see if it was true? The earlier forms that I showed you, you will plug them in the same numbers. So here we have A equals C minus B, well, is that true? A is 2, B is 4, C is 6. Here, we're using this form, A equals C minus B. For C, we have 6, so we substitute in our value for C, minus B. B here, which we know is 4. Now, is this true? Is that true? 6 minus 4 does equal 2. So yes, that's true. That means this is true. See, the purpose of the letters are to show you what you would do to numbers if numbers were in that place. In algebra, we use letters to show the laws and the principles rather than keep showing a list of numbers. This is a proof that this form is correct. This proof is to prove to you that I rearranged the variables in the formula correctly. The fact that this equals a true statement. Now that was for A equals C minus B. Let's try B equals C minus A. So first we substitute in our value for B. Our value for B is 4. We say, does 4 equal B equals C minus A? Does 4 equal 6 minus 2? 4 does equal 6 minus 2. 6 minus 2 is 4. That means that is true. Now let's say we're still using this same format. But let's say we started in the 4th step. We used to do B equals C minus A. Let's say, how would these equations relate to each other if I move C to the other side of the equation? If I move C to the other side of the equation. To do that, we add negative C to both sides. Add negative C to both sides. Therefore, I have B I'm going to have a B plus negative C equals C plus a negative C minus A. So here we know C's cancel out. Or you get 0 minus A. Now here, that becomes B minus C. And finally we get B minus C equals just a negative A. Because 0 minus A equals 0. Adding 0 or subtracting a number from 0 does not change a number. So that becomes B minus C equals negative A. So here we know what we get. We get negative A. So here we have negative A equals B minus C. And here you look at a positive A, this is a negative of that. You see? So A equals C minus B, whereas